Hello guys, so I'm your educator for this question from the topic ellipse of mathematics. Let us read out the question once. Find the locus of foot of perpendicular drawn from focus on any tangent for the ellipse. So if you guys remember the properties of ellipse, then without even touching pen and paper, you might have answered this question. Okay. The answer to this question will be auxiliary circle. Now, let me remind you that property. Okay. The property says that the locus of the foot of perpendicular drawn from any foci to any tangent of the given ellipse is nothing but the auxiliary circle of that ellipse. Now, the another question that might strike to your mind is what is auxiliary circle? Let me remind you that too. Auxiliary circle is the one with the same center as that of the ellipse and whose radius is nothing but the semi-major axis of the ellipse. Okay, so in order to prove this property, let us consider our standard ellipse whose equation is x square by a square plus y square by b square equals to 1. And also you can see over here that a is greater than b because the major axis is along x-axis and the minor axis is along y-axis. Also the relation b square is equals to a square into 1 minus e square will be valid over here, okay, because it is our standard ellipse with the center as origin. So wherever required, we can use this relation in this question. Okay. So now in order to prove this, I am considering a random point on this ellipse and name it as M. Okay. Now let me draw the tangent at this point M. This is what a random tangent. This is a variable tangent because the point M is a random point that is selected on this ellipse. Now, since the point M is variable implies the tangent is variable, this implies the slope of this tangent is also variable. Now, let us assume the slope of this tangent to be M. So, this M over here is what? A variable quantity. This M is what? A variable quantity. Okay. Now, let us consider one of the foci of this ellipse and name it as S, and you all know that the coordinate of this point S will be a comma 0. Let us plot the perpendicular from this foci to the given random or variable tangent, and let us assume the coordinates of the foot of perpendicular to be h comma k. Why? Because we have to find the locus of this point, hence we have assumed the coordinates of that point to be h comma k. As we all guys know that the equation of tangent having slope m having slope equals to m to the given standard ellipse is y is equals to what? Mx plus minus under root a square m square plus b square. A square m square plus b square. This plus minus over here indicates that two tangents will exist of same slope to the given ellipse. This is known to us, okay, by the figure itself. It's visible to us, okay. Now let us deduce some relations between h and k from the given equation. Since the point P is lying on this tangent implies the point P must be satisfying its equation. Okay, since the point P is lying on this tangent implies the point P must be satisfying its equation. This implies K is equals to MH plus minus under root A square M square plus B square. This is one of the relation that we have deduced between H, K and M. Since M is variable, so we have to eliminate M from here. Okay, in order to eliminate them, we need to deduce one more equation from the given conditions. So let us think about that. Since we can observe that the slope of this line PS, okay, will be what? K minus 0 upon H minus A. Why? Because the slope of line joining 2 points x1, y1 and x2, y2 is what? x1, y1 and x2, y2 is what? y2 minus y1 upon x2 minus x1 implies slope of PS is equals to what? K minus 0 upon H minus AE. Okay. Also, since this PS is perpendicular to the given tangent and we have assumed the slope of this tangent to be m. This implies the slope of PS will be minus 1 by m, because the two lines which are perpendicular to each other, the product of their slopes will be equals to what? Minus 1. So this we can write it as what? This is also equals to minus 1 by m. So the second condition from here that we can deduce is this: Km is equals to AE minus H. This is the second condition. Okay. So we have got the two conditions. Let me circle out those two conditions. From these two conditions, we have to eliminate what? M. Now, there are many possibilities to eliminate M from this situation, but we will follow this following procedure, okay, in order to reduce the time to solve this question, okay. So what we'll do is, we'll take MH on the LHS from the equation 1 and square on both the sides of that equation. What we'll get is K minus MH whole square is equals to A square M square plus B square. Let us name it as equation number 3 or condition number 3. Okay. Similarly, from the equation number 2, what we'll do is we'll just take H from RHS to LHS and we'll square on both the sides. So Km plus H whole square will be equals to what? A square E square. Let us name it as condition number 4. Now we'll add these two equations, equation number 3 and equation number 4. We'll add these two equations, equation number 3 and equation number 4, and let us see what we'll get. After adding, what we'll get is K minus MH whole square plus Km plus H whole square equals to A square M square plus B square plus A square E square. Okay. Now let us open this bracket whole square. So after solving, what we will get is the coefficient of K square will be equals to 1 plus M square. In a similar manner, the coefficient of H square will be what? 1 plus M square. And the term of 2AB will get cancelled out. Okay. And over here, what we can see is, okay, by just observing the relation B square is equals to A square into 1 minus E square, what you can conclude over here, could you please just let me know that A square M square, okay, plus, we'll put A square into 1 minus E square plus A square E square. So minus A square E square and plus A square E square will get cancelled out over here. Okay, 1 plus M square will be common and we'll get H square plus K square on LHS equals to, so, and from here we'll just get only A square plus A square M square. So let us take A square as common. We'll get 1 plus M square in the bracket. So cancelling out 1 plus M square term from both the side, because 1 plus M square cannot be 0, so we can cancel it out from both the sides of the equation. Okay, there won't be any root loss. And finally what we'll get is the locus, the equation of the locus, the relation between H and K, which is independent of M, which was variable. Okay, so this is our locus. Finally we can replace H by X and K by Y. So the final locus is a circle, and this circle is nothing but what? Auxiliary circle of the given ellipse. Thank you guys.